All right, welcome to lesson 5.2. This is buy or sell a car. We're going to be talking about data samples. So let's jump into the vocabulary section. First word we have here is ascending and descending order. All we got to do is arrange the data in order from least to greatest. If we start at the bottom, go to the top, kind of like a plane taking off, least to greatest, that is ascending. You're going up on the plane, you're ascending. If you are going from greatest to least, so if you're already in flight and you're going down to land, greatest to least, that is descending. So that's ascending and descending order. Next word is arithmetic mean, also known as the average. This is what we normally think of when we think of average. This is adding up all the values in the data set and then dividing by the number of data samples. That's the arithmetic mean. Next word is median. This is the value of the middle data point when the data samples are placed in ascending order. So we get whatever data sample, we put all of them in order from least to greatest, ascending order, and then we find the one in the middle. That is the median. Next word is outlier. This is a piece of data that is extremely different than the rest of the data. So if we're buying apples, for example, and every apple is $1, and then there's this one apple that we pay $25 for, that is a unique position. That's probably the poisoned apple that the witch put together. So that will skew the rest of the data. This is an outlier. It's not like all the other ones. It's different. Next vocabulary word is range. This is the difference between the greatest number in the data sample and the least number in the data sample. That will tell you how what the range is between these data samples. Next we have mode. This is the most occurring item. So if you're looking at your data sample and the number 7 shows up the most, that is the mode. Let's say, for example, you have the number 7 and the number 10 in your data sample and they show up the same amount of times and they show up the most. You can have bimodal, which is 2 modes in one data sample. All right, last vocabulary word is upper and lower quartile and interquartile ranges. In order for us to find the upper and lower quartiles and the interquartile range, we need to set this data sample in order. So I'm going to start with the lowest number here. I'm going to go in ascending order from lowest to largest. So 21 is the first number. And then, you know what, I'm not going to use commas there, just going to leave it like that. So 21, we used it. The next biggest number is going to be 22. There we go. We got 1, 2 23s. So we got the 23s out of the way. We got 1, 2, 3 25s. And that leaves us with the 27 and a 28. And a 28. So there's our entire data sample in order. And so now what we're going to do is find the number of data samples. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different numbers. To get to the middle, I'm going to go 4 from the left, right? 1, 2, 3, 4. That's going to be right about here. Or you know what? I'm going to use a different number, a different color here. It's going to be right here. 1, 2, 3, 4. 1, 2, 3, 4 from the right is going to be right here. So this number right here in the middle, 25, is going to be the number that is going to be the median, the one right in the middle. Now we have 4 numbers to the left, 4 numbers to the right. So in between those two numbers and in between those two numbers are our Q1 and our Q3, our quartile ranges. Now the median is also known as Q2. And now we've broken up the data into 4 different data sections, 4 different quartiles. So we got the upper quartile, Q3, right? So let me pick a different color here. So we got the upper quartile, Q3. We have the lower quartile, Q1. And then the interquartile range is going to be Q3, probably use a different color, minus Q1. That is what we call the interquartile range. All right, so we're going to find the arithmetic average, or also known as the mean. People often forget what the mean means. Pun intended. But actually it's just when we add up all the data points divided by the number of data points that there are in this particular sample. The average, when you think of average, this is what you normally think of. It's actually the arithmetic mean. So we got 25, 35, 35, 25, 40, 20, 25, 40, and 45. Step number one is we're going to add up all those numbers. So when we do that, we get a total of 290. Right? That's step one when we add up all those numbers. Step two says divide the total by the number of data samples. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 different numbers right there. So we're going to divide 290 by 9, and that's going to give us our mean. And so when we do that, we actually get a decimal. We get 32.222 repeating. So that's actually the answer for the arithmetic mean. All right, for this example, we're going to be talking about how does an outlier affect the mean but not the median. So first thing we need to understand is what is the median, what is the mean. All right, so this is the same data points that we had in the previous example. And let's talk about the mean first. So the mean, which we're going to put in red here, the mean is the same data numbers. So if we added all these up, they're going to add up to 290. Right? There's 9 data samples there, so when we divided by 9, we ended up with, I think it was 32.22. Oops, 32.22 repeating. Right? That was the mean. Okay. However, the median is the number in the middle. So if there's 9 data points here, we can go 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. The 9th number is this number right here. That means that the median is 35. Right? Okay, so if the median is 35, the mean is 32.22, how does an outlier affect it? An outlier, remember, is something that skews the numbers. It's weird, right? So if this was like the price of, I don't know, let's say this was the price of a video game. But then we went out to the store and we noticed that this video game over here, there's this other video game that was like $1,000. It's not the normal one. It's just an outlier, right? This one video game is $1,000. How does it affect the median? How does it affect the mean? Well, now, as far as the median is concerned, I'm going to go back to the median here. I'm going to use purple for the median. The median is the number in the middle. So we have one extra data point. So now we have 1, 2, 3, 4, 5 on this side. 1, 2, 3, 4, 5 on this side. The number is right in between that, the average of 35 and 35. So the median actually stays the same. The median number didn't change. But when it comes to the mean, let's use different colors. Let's use green for the mean now again. So the mean, now we have to add up all these numbers. And instead of having 290 as when I add up all these numbers, I'd have 1,000 of that. I have actually 1290 that I need to account for. Right? And I'm going to divide not by 9, but by 10 data samples. So when I do that, my mean, my average now is not 32.22, it's 129. That's the new mean. So having an outlier really affects the mean because we're taking into account all the values. And when we divide by the number of data points, the value gets skewed because I have that one video game that sold for $1,000. Right? And so now I'm saying that if I was to use the mean as the average, that my average price of a video game is $129. When in fact, if you look at the data, it's not really true, right? The average price of video game is about $32 to $35, but the mean skewed that. However, if we use the median, the number in the middle, it didn't move at all. It stayed in the same spot because once we put these in ascending order, even if I have an outlier, the value of that outlier is not skewing the data as much. So that is how an outlier affects the mean, but not the median. All right, we're going to find the median of the following data points. We kind of already did this, but I just want to make sure you guys understand how to find the median of a data sample. So in this data sample, notice that the 9 numbers that we have here are not in ascending order. So the first thing we got to do is place them in ascending order from least to greatest. So I'm just going to cheat and plop these in here for you. So they're now in ascending order, least to greatest. And what we're going to do here is we're going to find the number in the middle. So we got to look at how many data points we have here. We have 9. So if I was trying to split up 9, it'd be 4.5 and 4.5. In other words, I need to come from the left side 4 digits, from the right side 4 digits, and the number that's in the middle, because it's an odd number, is going to be the number that we're going to look at is the median. Okay, so for example, we got we got 1, 2, 3, 4 numbers on this side. We got 1, 2, 3, 4 numbers on this side, and notice that 35 is the one in the middle. That is going to be our median. Now let's assume there were 8 numbers. So what we're gonna do is I am going to magically cut out our last digit here. Bloop, it is gone, right? Okay, so if I only have 8 numbers in my data sample, right now, when I look at 8 numbers, what's the number in the middle? Well, it's still going to be 4 on this side, 4 from this side, which means I have this number right here in the middle, in between 25 and 35. So to find the median when it's between 2 numbers like that, all we got to do is take 25, we're going to add it to 35. All right, that's a horrible 3, but that's a 3. And that's going to be 60. And then when we divide that by the 2 numbers in our data sample here, that means that our median in this case is going to be 30. All right, so the number in between 25 and 35 is going to be 30, and that's what we would write. I'm going to write that 30. That would be right here. That would be our number for the median. All right, last example we got here. You're going to find the quartiles for the following data. So in order for us to find the quartiles, we need to find Q1, the median, also known as Q2, and Q3. So for us to be able to do that, we need to have this data sample in ascending order. So step number 1, put them in order. Boom, we just did. See? Magic. Okay, so now we have the data in ascending order. First thing we need to do, this is a find the median game, right? Find the number in the middle. We're going to do that 3 times and we should be done with this. Okay, so first of all, we have 9 data points in this sample. So the middle of 9 is between 4 and 4. It's that 5th number in between. So we're going to go 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side. That number in the middle, that median is going to be 35 right there. Boom. So this is our median, also known as our Q2. Okay, so now from this point, this number is included. So since we struck a line through it, it no longer counts. That means to the left we have 4 numbers, and to the right we have 4 numbers. The middle of this 4 numbers lies right here in between 20 and 25. I'm going to use a new number. I'm going to use green. Right? So in between that 25 and 25, what is the number that lies, or what's the average between 25 and 25? It's going to be 25, right? So the the Q1 is going to be the number 25. And we're going to do the same thing on the other side. There's 4 numbers on the right side. In between these 2 numbers right here is going to be our Q3. That's a horrible 3 again. In between that, there we go. And the average between 40 and 40 is going to be 40. So what are the quartiles for this? Well, I'm going to use the colors that are there. So for Q1, our value for Q1 is 25. For Q2, a horrible 2. For Q2, our number is 35. And then for Q3, our number is 40. All right, so you'll hear this known as the quartiles. You might also hear upper and lower quartiles. So Q1 and Q3 are upper and lower. Q3 is the upper. Whereas Q1 is the lower. Okay, so you can have upper or lower quartiles. You can call them Q1, Q2, Q3, and we're going to use those a little bit later too. So there you go.